Okay, now we're going to balance the reaction of silver nitrate and calcium acetate to form silver acetate and calcium nitrate. We haven't studied this reaction type yet, but this is called a double replacement reaction. And if we look at this, we can see a pattern. On the left side of the equation, the silver is with the nitrate, but on the right side, the calcium is with the nitrate. And then here on the left side, the calcium is with the acetate. On the right side, the silver is with the acetate. So essentially what we have going on is the nitrate is going to come over here onto the calcium, and the acetate's going to go over here onto the silver. That makes this equation easy to balance. Now, so far we've been balancing each element, but it would get very cumbersome to balance the carbon and the hydrogen and the oxygen, all three separately. The oxygen would be really cumbersome because it appears in all four of these formulas. But what we can do is we can balance this nitrate, NO3-, and this acetate, C2H3O2, as a whole, and that will make it much easier. So I'm going to start by balancing silver. I have one silver on each side. Silver is balanced. Next, we'll balance calcium. I have one calcium on each side. It is balanced. Next, we'll balance the acetate ion, the C2H3O2. I'm going to need a 2 here in front of the silver to balance that. A 2 in front of the silver. That threw my silver out of balance, so I'm going to need a 2 over here as well. Now next, I can balance the nitrate, the NO3. I have 2 NO3s here and 2 NO3s over here. So at this point, I should be balanced. 2 silvers on each side, 2 nitrates, NO3s on each side, 1 calcium on each side, and 2 C2H3O2 acetates on each side. So I'm just going to clean this up a bit and get rid of some of my underlines and arrows. And then we should have here a balanced equation. And that was much easier than balancing each of these elements separately.